आवाज आ रही है शायद। हाँ, सभी को सादर प्रणाम। ये ना इस पे आवाज गूंज रही है टैब पे। हम इसके वॉल्यूम बंद कर दें, आवाज आ रही है, रिपीट इकोइंग हो रहा है। इसकी वॉल्यूम कम कर। तो सभी को सादर प्रणाम। मैं डॉक्टर सोनिया आप सभी का यहाँ पे बहुत बहुत स्वागत करती हूँ फिर से एक बार। और अभी हम एक वक्तव्य के लिए यहाँ पर आए हैं, जुड़े हैं, जिसमें डॉक्टर अनुराधा गुप्ता हमारे बीच में जुड़ी हुई हैं, दिल्ली यूनिवर्सिटी से मैम यहाँ पर आमंत्रित हैं। और आपको एक बात और बताना चाहूंगी कि ये जो हम अभी आप देख रहे हैं पीजी कैरिकुलम कोर्स वर्क के लिए हम यहाँ पर जुड़े हैं, लेकिन ये यात्रा हमने प्रारंभ की थी। जो हमेशा से जब भी हम इस वर्कशॉप को करते हैं तो आपको बताया जाता है कि भाई हम एक यात्रा प्रारंभ कर रहे हैं, और वो यात्रा हमारी प्रारंभ हुई थी 2022 में 22 अगस्त। और 22 अगस्त से 28 अगस्त 7 दिवसीय एक कार्यशाला का शुभारंभ हुआ था वैदिक गणित के ऊपर, जिसमें हमारे 21 स्पीकर जुड़े थे अलग अलग देश विदेश से। और वो बहुत फ्रूटफुल रही थी। उसमें अलग अलग लोगों को, मतलब लोगों को अवगत कराना उसका काम था कि वैदिक गणित क्या है, हमारा भारतीय गणित के दर्शन क्या है, या भारतीय गणित क्या है। उसी के समकक्ष फिर आगे बढ़े तो 2023 में 29-30 मार्च को फिर उसी के आगे हमने वैदिक गणित के नए आयाम पर 2 दिवसीय कार्यशाला का आयोजन हुआ था गणित विभाग की ओर से सीसीएस यूनिवर्सिटी। उसमें वैदिक गणित को लेकर जितने भी नए आयाम हैं उनकी परिकल्पनाओं पर चर्चा हुई थी, और बहुत सारे वक्तव्य और बहुत सारे श्रोताओं के भी वहां पर व्यूज लिए गए थे। सेंटर ऑफ एक्सीलेंस भी इसी पर मिला डिपार्टमेंट को। डिपार्टमेंट ऑफ मैथमेटिक्स सीसीएस यूनिवर्सिटी को सेंटर ऑफ एक्सीलेंस जो मिला वो न्यू डायमेंशंस इन वैदिक मैथमेटिक्स के ऊपर मिला, और उसकी रिपोर्ट भी बिल्कुल जा चुकी है। और अब 2024 में उसी यात्रा को आगे बढ़ाते हुए हम 2 दिवसीय कार्यशाला का शुभारंभ कर चुके हैं, जिसका इनॉग्रल सेशन अभी पूरा हुआ है। और अब हम टेक्निकल सेशन के साथ साथ इसके पैरेलल एक टेक्निकल सेशन भी चलेगा। और हम यहाँ पर उपस्थित हुए हैं इंटीग्रेशन ऑफ आईकेएस इन पीजी कैरिकुलम ऑफ मैथमेटिक्स इन द लाइट ऑफ एनईपी 2020। मैं आपको बता दूं कि इस कार्यशाला का उद्देश्य क्या है। जो हम बात करते हैं भारतीय ज्ञान परंपरा की, तो भारतीय ज्ञान परंपरा का समावेश एनईपी 2020 को अंतर्निहित करते हुए हम अपने जो गणित का पाठ्यक्रम है, चाहे वो यूजी हो चाहे वो पीजी हो, तो उस पाठ्यक्रम में भारतीय ज्ञान परंपरा को कैसे समावेशित किया जा सकता है, इस कार्यशाला का उद्देश्य है ये। और इस उद्देश्य की पूर्ति हो, इसी के लिए हम सब लोग यहाँ पर उपस्थित हुए हैं। और उसी को आगे बढ़ाते हुए मैं अभी अनुराधा मैम को यहाँ पर आमंत्रित करना चाहूंगी। मैम, आप सादर आमंत्रित हैं, कृपया मंच पर पधारें। मैम के बारे में थोड़ा सा ब्रीफ आपको बताना चाहूंगी। मैम इज अ प्रोफेसर इन दिल्ली कॉलेज ऑफ आर्ट्स एंड कॉमर्स, यूनिवर्सिटी ऑफ दिल्ली। She has additional skills like problem solving, leadership, collaboration, time management, adaptability, critical thinking, handling pressure, strong work ethic, hard working. Her research publications are total around 71 publications and 181 citations at Google Scholar. There are 4 books have been published of ma'am. Her professional experience for UG is 34 years. That is a vast experience, ma'am. For PG graduate, 18-year experience she is having. She has delivered many talks and attended many training programs in many workshops and national international seminars. Ma'am, you are most welcome. मैम, आज का जो वक्तव्य है उसकी थीम को मैं थोड़ा सा बताना चाहूंगी। रामानुजन के विषय में मैम का लेक्चर है, और रामानुजन वर्क को मैम थोड़ा सा जागृत करना चाहेंगी, सभी को बताना चाहेंगी कि रामानुजन ने क्या कार्य किया है, क्योंकि उनकी जो अनसुलझी गुत्थियां हैं वो अभी तक कोई नहीं सुलझा पाया है। तो उसी परिप्रेक्ष्य में हम आगे बढ़ना चाहेंगे। मैम, आप सादर आमंत्रित हैं।
I would like to thank the Department of Mathematics, CCSU University. Special thanks to Professor Shivraj Singh ji. We all know Ramanujan, the genius Ramanujan. So today's lecture is on his work. He worked in number theory and he has written so much on number theory that there are infinite number of research problems are there. So if you want to do research in number theory, you study Ramanujan notebooks. There are 7 volumes available and 2 notebooks, separate notebooks. So you can study these. So I am taking today the topic Ramanujan's infinite nested in radicals. Let me explain you the 3 words infinite, nested, and radicals. What is radical? Basically, this is the fractional power of anything. Say, if we take x raised to the power 1 by 3, x raised to the power 1 by 4, or x raised to the power 2 by 5, etc., these are radicals. What is nested? If we consider under root of x raised to the power half, under root of x raised to the power 1 by 3. This is nested. One radical inside another. So this is nested. But what about infinite? Infinite means that if we have x, under root of x, under root of x, and this is going infinitely. So this is known as infinite nested radical. So in the year 1911, in the Journal of Indian Mathematical Society, the next number is 4, and adjacent to 4, we have 3 and 5. We can write this 4 square as 3 into 5 plus 1. 4 square is 3 into 5 plus 1. So we can write this as under root of 1 plus 2, and this 4 is nothing but under root of 4 square. So it means 4 square from here is under root of 1 plus 2. Then we can write this as under root of 1 plus 3 into 5. Then we have 5. 5 adjacent to 5, we have 4 and 6. 4 and 6. It means 5 square can be written as 4 into 6 plus 1. Okay. So we replace this 5 as this is under root of 1 plus 2 under root of 1 plus 3 into 5 square. Just replace this value. This is 1 plus 2 under root of 1 plus 3 under root of 1 plus 4 into 6. You keep on doing like this. So ultimately we are getting the same thing. And you can see its value is 3. How wonderful is this? Now the next question arises, can we do it for all n? We have 1 plus 2, then 1 plus 3. But if we have in general, that if I take the value of n as 9 or 10, can we do it? Then in the year 1912, in volume 4 of the same journal, Ramanujan again published a paper in which he explained, then we can do it for all values of n. How? Let me proceed. Shall I erase? You want to write? Erase कर दो. लिख रहे हैं सब लोग ना. Okay. So how do we do it for all n? If I consider n plus 2, I can write this to be n plus 2 whole square. Just open this square, so it can be written as n square plus 4n plus 4. How can we write this? This can be written as under root of 1 plus, oops. One plus n square plus 4n plus 3. Okay. So further we can write this as 1 plus. If you just factorize n square plus 4n plus 3, we can write this as n plus 1 into n plus 3. Now, we can write this as 1 plus n plus 1, and this is under root of n plus 3 whole square. So further, if you just write n plus 3 whole square, this is 1 upon n plus 1, and this is under root of n square plus 6n plus 9. So further, you can write this as 1 plus n plus 1. Again, we can write this as 1 plus n square plus 6n plus 8. Again, you factorize. It is 1 plus n plus 1 under root of 1 plus. If you factorize n square plus 6n plus 8, so what you get? N plus 2 and n plus 4. So you can write this to be n plus 2, n plus 4. You keep on doing like this. So what is the next step? It will be 1 plus n plus 1 under root of 1 plus n plus 2 under root of 1 plus n plus 3 and so on. Now, you substitute the value. If you put n is equal to 1, so what happens if you put n is equal to 1 here? This is under root of 1 plus 2, under root of 1 plus 3, under root of 1 plus 4, and so on. And on this side, if you put n is equal to 1, this is going to be 3. So you can see this is true for all n. Similarly, you put n is equal to 3. So what you get? You are getting 5 is equal to under root of 1 plus 4 under root of 1 plus 5 under root of 1 plus 6, and this goes infinitely. So you can see that it is interesting to solve the infinite radicals. Now, next question is this the only way to solve it for n? No, there are several ways. Why I want to explain you this? Because I want to motivate you for further research that this is not the only way. So how do we proceed further? Shall I erase? So another way of finding this is that we took n plus 2. You can take this to be, say, x plus 1. You can further write this to be x plus 1 whole square. So this is equal to x square plus 2x plus 1. Further, I can write this to be 1 plus x into x plus 2. So this x plus 2 can be written as 1 plus x, 1 plus x plus 1. Okay. So further, I can write this to be 1 plus x under root of 1 plus x plus 1 whole square. So further, I can write this to be 1 plus x. Just open this. It is 1 plus x plus 1 whole square, or 2 times this plus x plus 1 whole square. So further, I can write this to be under root of 1 plus x under root of 1 plus x plus 1 into x plus 3 and so on. So you keep on doing like this. So you are getting this to be 1 plus x under root of 1 plus x plus 1 under root of 1 plus x plus 2 under root of 1 plus x plus 3 and so on. You just substitute the value. If I put x is equal to 2, so what are we getting? On this side, we are getting 3. And on this side, we are getting 1 plus 2, 1 plus 3, 1 plus 4, and so on. See, this is another method. This is also true for all x. If I suppose take x is equal to 124, so what happens? If you take 124, we are getting this to be 125, which is equal to under root of 1 plus 124, under root of 1 plus 125, under root of 1 plus 126, and so on. So for any value of x, which is an integer, which can be positive as well as negative, you can find out this infinite radical. Okay. Now, I gave two problems in the beginning, which Ramanujan posed. So let me give you the answer to the second. Shall I erase? So the second problem was, it was that what is the value of 6 plus 2 under root of 7 plus 3 under root of 8 plus 4 under root of 9 plus 5 and so on. This infinite radical. We start with 4. So 4 is under root of 4 square, which is 16. 16 can be written as 6 plus 10 because here the first is 6. So that is why we are breaking like this. This 10 can be written as 6 plus 5 into 2. Okay. So further we can write this to be, see here we have next is 2. It means we write this to be 6 plus 2 under root of 5 square. This 5 square, this can be written as 25. This is 25, which can be written as 7 plus 18 because the next is 7. So that is why we are breaking like this. So this 18 can be written as 6 plus 2 under root of 7, 18. The next number is here 3. So it means 18 can be written as 3 into 6. So we write this to be 3 into 6. So it can be written as 6 plus 2 under root of 7 plus 3 into 6 square. But what is 6 square? It is 36. But 36, if you just see, it is, next number is, we have 8. So we can write this to be 6 plus 2 under root of 7 plus 3. This is 36. So how do we write in a Siddhesha? 36. You need 8. It can be written as 8 plus 28. So this is 8 plus 28. You keep on doing like this, you will get this and see its answer is 4. So this is the answer 4. Right? Now again, the question arises. Is it true for all n? So let me give the proof that it is also true for all n. So if we consider n plus 3, we can write this to be n plus 3 whole square under root of this. And n square plus 6n plus 9. So further we can write this to be n plus 5 So we have taken 1 here, and out of this 9, we have taken 5. So how much is left? This is n square plus 5n plus 4. So how do we factorize n square plus 5n plus 4? This is one term. So this is n plus 5. And what about the second term? We can factorize it into n plus 1 into n plus 4. So further, how do we write this? We can write this as n plus 5 plus n plus 1 under root of n plus 4 whole square. You open the square, you have n plus 5 plus n plus 1, and you just open it, it is n square plus 8n plus 16. Again, you adjust the terms, n plus 5 plus n plus 1. Now, what do you need next? You need n plus 6 because it was n plus 5. So next term is n plus 6. So you just take out n plus 6. So it is n. One n we have taken and 6. So what is left? N square. One n we have taken 7n plus 10. So we factorize it. It is n plus 5 plus n plus 1 under root of n plus 6. If we just factorize what we are getting this to be 2 and 5. So it means this is n plus 2 and n plus 5. You keep on doing like this. Now you put n is equal to 1. If you put n is equal to 1, this side becomes 4. And on this side, we are getting 6 plus 2. N is equal to this 7 plus 8. Next is 8, 7 plus 3, 7 plus 3, sorry, 8 plus 4, and so on. So when you take n is equal to 1, we are getting here 4 is equal to under root of n plus 5. It is 6. Then we have n plus 1, 2. Then we have n plus 6, 7 plus 3. Then you keep on doing like this. So you can see it is true for all n. If you put n is equal to 2, you will get this to be 7 plus 3 plus and so on, right? So this was the general formula given by Ramanujan. Now next question arises that what happens? Is there any shortcut for all these? We know we have shortcuts also because we are also learning Vedic mathematics. We are getting shortcut methods also using sutras. So how do we get shortcuts for finding the infinite radicals? First, most of us have done this in 12th standard, that if we have infinite radicals of the form, say we have 2 under root of 2, under root of 2, under root of 2, and so on. How do we solve it? We write this to be equal to y. And this is infinite. So if we just remove 1, there is no impact. So it's squaring on both the sides, what we get, this is 2 under root of 2, under root of 2, and so on. So this is y squared, just square on both the sides. So this is again y, so we can write this to be 2y is equal to y square. So basically, which is y into y minus 2 is equal to 0. So the value of y, this is 2, y is 2. It means this infinite series, 2, 2, 2, and so on, basically its value is 2. This is also true for all n. Means that if I take 7, under root 7, under root 7, under root 7, and so on, this is also 7. If I consider under root 15, under root 15, under root 15, its value is coming out to be 15. This is also true for all n. Okay. किसमें? इसमें सूत्र नहीं, हम रामानुजन की नंबर थ्योरी लगा रहे हैं. मेरे हिसाब से लोकल स्थापना ध्यान से लगाया जा सकता है और उसको उस दृष्टिकोण से, हाँ, तो उस लोकल स्थापना ध्यान लगा करके इसको नहीं, हम दूसरी डायरेक्शन में करें. वैदिक गणित का कौन सा? Okay.
लोकल तो हर जगह है, लेकिन लोकल is
Then Ramanujan also gave the value of pi using this infinite radicals. How? He established that 2 upon pi can be written as under root of 2 divided by 2 plus, into 2 plus root 2 under root of 2 into 2 plus 2 plus root 2 by 2 and so on. Infinite radicals. Then if we just take the reciprocal of it, so what we get, this is pi, and you can see in the denominator, if we take k terms, this will be 2 raised to the power k. So we are taking this to be limit as k tending to infinity because this is infinite radicals, 2 raised to the power k. And what is inside? It is 2 plus root 2 plus root 2 plus and so on. So, and this is k minus 1 times. So using this formula, he obtained that the value of pi is going to be 3.17 approximately. Now, next very interesting thing, here we have product root 2 into root 2 into root 2. But if there is plus in between, then what happens? Means that if we have a plus under root of a plus under root of a plus under root of a plus, this is infinite times going up to infinity. So there is a formula for this. He developed that this is root of 4a plus 1 divided by 2. You just check. If I want to find out the value of 6 plus root 6 plus under root of 6 plus and so on. So what is the value? It means a is 6. So this is going to be 4 into 6 plus 1 divided by 2. So this is 25, which is root 25 is 5. So 5 plus 1 divided by 2, this is equal to 3. Okay, and this is also true for all values of n. Now, if you have minus instead of plus, we have minus, then what happens? That if suppose you want to find out a minus, root a minus, this is going up to infinity. Then the formula becomes under root of 4a plus 1. Instead of plus 1, we have minus 1 divided by 2. If suppose you want to find out the value of say 4 minus root 4 minus up to infinity. So this is going to be a is 4. So this is 16 plus 1, 17 minus 1 divided by 2. And find the approximate value of root 17 and then you can calculate it. Now, the next is if we have mixed radicals. For example, we have this is 2 cube root of 4 under root of 2 cube root of 4 under root of 2 cube root of 4. We have here mixed radicals and this is going up to infinity. Right? Earlier we had only under root, similar type of radicals, but here we have mixed. So what we do? We can also find out this. Let us assume that this to be x. This is 2 cube root of 4 under root of 2 cube root of 4 and so on. The first is under root, means it is half, taking square on both the sides. So we get x square is equal to 2. This is cube root of 4 root 2 cube root of 4 up to infinity. Next is this is cube root. So we take cube on both the sides. So this is x raised to the power 6. 2 cube is 8 and whatever is left, this is left. This is again x. So we can write this to be 4x. This is 32x. If you just find out the value of x, this is x into x raised to the power 5 minus 32 is equal to 0. So basically the values of x are 0 and x is equal to 2. Right? So you can see the value of this is going to infinity. This comes out to be 2. Okay. Now the next question arises. Can we connect these infinite radicals with functions? Can we use calculus differentiation in finding the values of these infinite radicals? So let us do it. So this is value of infinite radicals using calculus. Very interesting concept because we can develop calculus using this. So let us consider a function f, which is defined from -1 to infinity to 0 to infinity, semi-closed interval, such that fx is equal to under root of 1 plus x f of x plus 1. Let us substitute the value of f of x plus 1 using the same function. So it means we need to replace x by x plus 1. So what we have 1 plus x under root of 1 plus x plus 1 into f of x plus 1. Similarly, f of x plus 2. Similarly, you can substitute the value of f of x plus 2. So it is 1 plus x under root of 1 plus x plus 1 under root of 1 plus x plus 2 f of x plus 3 and so on up to infinity. You can do it. Okay. Now, if you substitute here x is equal to 2, what happens? Put x is equal to 2. You are getting f2 is equal to under root of 1 plus 2, 1 plus 3, under root of 1 plus 4, under 1 plus 5. You can see that we have the same infinite radical, which I explained you, right? The same radical. But here the problem is that we need to calculate the value of f2, which should come out to be 3. So how do we calculate it? Using differentiation.
X is equal to -1 there.
किसकी जगह?
Instead of x is equal to, you can
हाँ.
take x is equal to -1.
अभी करती हूँ, वो भी करती हूँ. Erase कर. Okay. So I need this. So let me take first x is equal to 0, then x is equal to -1. So if you put x is equal to 0, so what happens? f0 is equal to under root of 1 plus 0 into f of 1. So this is equal to 1. So the value of f0 is 1. Okay. Now next, if you put f is equal to -1, what is f of -1? This is going to be 1 minus 1 f of 0. But f of 0, we have obtained this to be 1. So it is 1 minus 1. This is equal to 0. So f of -1 is coming out to be 0. Now, if we square on both the sides, so we note down these things because we need it. First is f of -1 is coming out to be 0. F of 2 is the series and f of 0 is equal to 1. Just square the given function on both the sides. So we are getting f of x whole square is equal to 1 plus x f of x plus 1. Differentiate on both the sides with respect to x. So what you get? This is 2 times f of x into f dash x is equal to f of x plus 1 plus x f dash x plus 1. Okay. Now we put x is equal to -1 because already we know the value of f of -1. So if you put x is equal to -1 here, what you get? 2 of f of minus 1, f dash minus 1 is equal to f of 0 minus 1 f dash 0. Okay, but f of minus 1 is 0, so this part is 0. f0 is equal to 1. So this is 0 is equal to 1 minus f dash 0. So from here we are getting f dash is equal to 1. So let us write f dash 0 is equal to 1. Okay. Now we again put x is equal to 0 in this. So if we put x is equal to 0, what happens? This is 2 f0 f dash 0 is equal to f of 1 plus 0 times f dash 1. Okay. So what is the value of f of 1? f0 is 1 from here. F dash 0 is 1. So f1 is coming out to be 2. Okay. So the last step is in the given function, we put x is equal to 1. So what you are getting? F of 1 is equal to under root of 1 plus f2. f1 is 2. We just obtained f of 1 is equal to 2. It means we have this is 2 square on both the sides. So 2 square is equal to 1 plus f2. So what is the value of f2? It is equal to 3. So we are getting f2 is equal to 3 using differentiation. Okay. So in this way, you can solve so many infinite radicals. There are so many open problems also. If you just go through the diaries of Ramanujan, there are infinite number of open problems. So if you want to do research in number theory, you just go through. These are available in the market. If you want soft copy, I have soft copy of all these notebooks. So I can share with you. Okay, so thank you so much.
मैम रामानुजन वर्क पर जो आपने उनकी नंबर थ्योरी पर जो वक्तव्य दिया वो बहुत ही ज्ञानवर्धक है और इनके कार्य को अगर बहुत ध्यान से समझा जाए तो पता नहीं कितना कुछ है समझने के लिए और उसको समझाने के लिए बहुत बहुत आपका धन्यवाद। इसी के साथ मैं सभी को आमंत्रित करना चाहूँगी लंच के लिए और सभी सादर अच्छा ओके पहले मैम को हम गेस्ट ऑफ ऑनर के मोमेंटो के साथ में सम्मानित करना चाहेंगे। मैं आमंत्रित करूँगी प्रोफेसर शिवराज सर को कि सर आए और मैम को मोमेंटो देकर सम्मानित करें। बाकी भी अजेंद्र मलिक सर प्लीज, ब्रजेश कंबुलजा सर आप सादर आमंत्रित हैं। Once again, ma'am, thank you so much for coming in this workshop. और सभी सादर आमंत्रित हैं लंच के लिए और इसके बाद में हम 3 बजे दोबारा मिलेंगे यहीं पर। हाँ 3 बजे 2:45 ओके 2:45 हाँ 2:45 हमें लंच ब्रेक थोड़ा छोटा करना पड़ेगा तो 2:45 पर हम दोबारा मिलेंगे और उसमें हम 2 पैरेलल सेशंस चलेंगे। एक टेक्निकल सेशन होगा और एक इधर प्रेजेंटेशन ऑफ सिलेबस होगा और जिसके भी पेपर प्रेजेंटेशन है टेक्निकल सेशन वाले उधर चले जाएंगे और पेपर प्रेजेंटेशन के लिए कुछ लोग यहाँ पे रुकेंगे। थैंक यू।
Thank you.